Hello everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 9E. Myself, Siddhesh Rajendra Mughal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held on 4th April in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session today. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session. Our first chair for this session is Dr. Amit Sharma. Dr. Amit Sharma is an assistant professor, selection grade, CSIT, IIS deemed to be University, Jaipur, India.
Good morning,
So,
all. Myself,
yes,
Dr. Amit Sharma, Associate
And
Professor
just a
Vivekananda.
second, sir. I think so. Siddhesh has raised some another passenger intro. Just a
just a
second.
second, sir, just a second.
Should give the intro of your like on behalf of Siddhesh. Like Dr. Amit Sharma is an associate professor in the Department of Computer Science and Applications at Vivekananda Global University, Jaipur, India. He has expertise in AI, machine learning, the Internet of Things, image processing, and AutoCAD, providing training to students globally. He has published numerous research articles in reputed Scopus index journals and conferences. His research interests include image processing, IoT, machine learning, deep learning, and computer vision. Welcome, sir, in this session for the present. If you have any remarks for presenters.
Thank you. Please start the session.
Yes.
Thank you, sir. Our second chair for this session, just a second. Our second chair for this session is Professor Jagdishan Srinivasan. Professor Jagdishan Srinivasan is an assistant professor senior grade at Vellore Institute of Technology, India, with extensive experience in higher education, skilled in C++, Windows Server, Java, and network design. He has published numerous SCI Index journal articles, conference papers, and intentionally recognized book chapters. His research interests include network security, intrusion detection, cross-layer design, wireless ad hoc networks, and cybersecurity. Sir, I welcome you to the session. Sir, would you like to give any opening remarks to the participants? Sir, your mic is mute.
Yes, sir. Thank you. Thank you very much for introduction to for me, and I'm very much pleasure to part of your ninth international conference of information and communication technology for intelligent systems, and it's a very good opportunity for me and all artists to present your new innovation ideas and to share with among the peoples. It is helpful for our country also. Thank you very much. Thank you.
Thank you, sir. Now, I would like to start with the papers. Next presentation is by Sneha Sinoy. She is presenting the paper titled AI Enhanced Education, Personalized Learning and Performance Prediction Models. Sneha ma'am, are you there?
Yes.
Okay, ma'am, you can start your presentation. Just a second.
I'll just share my screen 1 second.
Yeah, you can share your screen now.
Everyone, I'm Sneha Sinoy from BITS Pilani Dubai campus, and I'll be presenting our research on AI-enhanced education, personalized learning, and performance prediction models. This project was done in collaboration with Kaveri Pathak and Miss Manisha. So let's have a quick overview of what all we'll be going through in this. And so we'll start off with the introduction, then move on to the objectives of our study, then the research gap that we found in our literature review, and then we'll explore the data set and understand the methodologies that we used. And then we'll have our results in comparison and move on to our conclusion. So starting off with the introduction. So traditional education follows a one-size-fits-all approach where students move at the same pace regardless of their individual capabilities. This makes it hard to personalize content or track individual learners' needs. Meanwhile, schools collect vast amounts of student data, grades, attendance, feedback that often goes underutilized. AI offers a powerful opportunity here. By using AI-based models, we can personalize learning paths and predict student performance early, enabling timely intervention and support. Moving on to the objectives of our study. Our primary objectives were to develop machine learning models that predict student outcomes, to personalize learning content based on individual performance, and to ultimately enhance learning experience and curriculum design through these insights. Now we have our the research gap we found from our literature review and our contribution to this research. So in our literature review, we identified three key gaps. Firstly, a lack of integrated framework combining prediction and personalization. Second, inconsistent accuracy of models across datasets. And third, personalization that was limited only to assessment feedback. So to address all of this, we built a combined framework using predictive modeling and ensemble learning techniques to deliver more reliable results. Moving on to our dataset and pre-processing. We use structured academic data from the UCI student performance dataset, which includes grades, quiz scores, attendance, study hours, and course feedback. So the pre-processing included handling missing values through statistical imputation, scaling and encoding data for ML readiness, and finally using correlation matrices for feature selection to keep only relevant predictors. Now we have our methodology and the machine learning models that we used. So we used 5 machine learning models, which is presented here. I will briefly explain each of them. So logistic regression. So this is a simple but powerful linear classification that works well for binary classification, such as pass or fail in this case. Then it's also efficient and gives us a baseline to compare other models. Now decision tree, this model creates an if-then rules to predict outcomes. Now we have random forest, which is an ensemble of decision trees that reduces overfitting and enhances generalization. So it typically performs well on structured data. Now support vector machines tries to find the best hyperplane that separates the classes. Now it is effective in high dimensional spaces and uses kernel tricks for nonlinear data. Now k-nearest neighbor is a symbol instance-based algorithm that classifies based on the majority label among nearby points. While intuitive, it's computationally expensive on large datasets. Along with all of this, we also use the cross-validation, K-fold cross-validation to evaluate our models and reduce the bias. And we assess performance using the 4 evaluation matrices: accuracy, precision, recall, and F1 score. Now let's look into our results. So after training and testing each model, KNN gave the strongest initial results, but after hyperparameter tuning, so here we can see that KNN has an accuracy of 75.95%, and it has the strongest results for both the classes. There's a class 0 and class 1, which corresponds to pass or fail. And but after we performed hyperparameter tuning, you can see that the random forest the accuracy was highest compared to the other models that we tried. And we also found that the individual models had like strengths and weaknesses, which we wanted to combine together into one single model. So now we'll talk about that, which is the ensemble model voting classifier. So to combine the strengths of top performing models, we use voting classifier, an ensemble that aggregates predictions from random forest, SVM, and logistic regression. So using soft voting, it selects the class with the highest overall probability and improves stability and performance. So this is the results of the voting classifier, which performed the best compared to all the other models. And as you can see, we had an accuracy of 95.28% to predict the pass class and the fail class. And yeah, so this is a diagram to show the increase in accuracy over the different models that we tried. Now we have the conclusion. So we basically developed a predictive framework to support personalized learning, and we fine-tuned individual machine learning models and combined them into a higher performing ensemble. The voting classifier delivered the best balance of performance and generalization. These predictions can be used to identify at-risk students early and personalize support. Lastly, we highlighted the need for ethical and inclusive AI practices in education. Thank you for your time.
Okay, one question from my side.
Yes, sir.
AI-driven model into the traditional education system, how we optimized in
So
traditional
basically,
education system.
so in traditional education system, we can't really recognize which student is performing well or which student is performing lower. So we generally give attention to all the students equally. But then there are some students who need extra they need extra attention towards specific subjects, and the AI makes it more easier for us to predict which student will be better performing at certain subjects and which student will be worse based on their previous grades and scores.
Thank you.
Okay. Nice,
Is there
Sneha. Sneha, very nice presentation actually.
Thank you, sir.
So, can you please tell me that what is the ratio we're going to divide it your data sets and the training and testing level?
So just 1 second, I'll just stop the screen share. So we just give me a minute. So as per my code, we divided the training set into test size is 0.2, so the corresponding training size would be 0.8. So we use 80% of the data and tested it on 20% of the data, and we chose it at random.
Okay, ma'am. Thank you.
Thanks.
Thank you, Sneha.
Thank you.
Sarah ma'am, are you ready with your presentation?
Yes, I tried to solve my problem. I hope I can share my screen now.
Yeah, please try. Yeah, ma'am, it's visible now. You can start your presentation.
That's good. Okay, good day, everyone. And today I will present our performance evaluation of a semantic search engine for chemical food laboratories in Egypt, our country, Egypt. This works explores how MapReduce improves data retrieval from large RDF datasets. At the beginning, the volume of data in food labs is growing rapidly in Egypt. So our focus was to compare traditional single machine semantic search systems with a more scalable distributed solution using Hadoop. So there's two implementations evaluated, Gina TDB and Apache Rhea. Okay, sorry, my voice because I have some flu. For the problem statement, we started by identifying real problems in food labs. The use of the disorganized data formats, manual search methods, and inefficient information retrieval. So there is no data, structured data. It's always CSV, and it's very manual, slow for data retrieval, and there's no scalable search solution. So for our case study, to validate the need for our system, we distributed some surveys among chemists. The results for these distributed surveys showed that strong preference for semantic search for the chemist, and confirmed that the demand for scalable solution, because the traditional search is inefficient and the RDF-based search was preferred to solve this problem. Our system architecture was deployed in two models. The first one was Gina TDB single machine, and the other one, the distributed system leverage, Hadoop, and Apache Rea for the RDF data management and Sparkle query. For the RDF transformation, the data was converted from relational formats like CSV and Access into RDF triples using the OWL API and Turtle syntax, enabling semantic query. And at the end, we tried to evaluate our performance in the two sites, for the single machine and for the distributed one. Our evaluated metrics was for uploading time and for the query execution time. For the upload time, here we can see that the MapReduce is almost 3 times faster in uploading RDF data compared to that single machine setup. For 1 million triples, it took like 85 seconds for the single machine versus 30 seconds only using the MapReduce. And we tested for the 3 million triples. It took around 245 seconds for the upload of single machine versus 90 seconds for the MapReduce one. And the other comparison was the query time comparison. For the simple query, it took like 1,200 milliseconds for the single machine versus the other one distributed with 320 milliseconds. And for complex queries, it took around 3,500 milliseconds versus 980 milliseconds only for the distributed one. So the key findings for our research was that it confirmed that the distributed system is more efficient and better suited for the high data demands of the more modern food labs. It's better scalability and efficiency and faster access for all of the chemists. For our future work, for future enhancements, we plan to include machine learning for the query prediction and to move to the cloud deployment and to support real-time querying like Spark, and we can test other frameworks and compare it like Flink and Store. For the conclusion, our system demonstrated that real performance gains and a strong practical impact, making it a promising solution for the food labs for the chemists in Egypt, as it's scalable and strong real-world impact and sustainable performance improvements. Thank you.
Hello.
Hi, Doctor.
Yes. My side one question. Could you
Yes.
elaborate on how the use of MapReduce enhance the efficiency of symmetric search in large scale clinical food?
For what? Sorry, can you repeat the question?
Simple. My question is very simple.
Yes.
Could you elaborate on how the use of MapReduce enhance the efficiency of symmetric search in large scale chemical food laboratory data?
Yes. For the chemists in the Egypt, for the food labs, actually they use very huge data, and for searching they were using the manual, just papers, and we tried to make like simple search for them, but the data was huge. Sometimes it's like 3 million records or something for them. So it's updated annually. So we try to enhance the performance for them to use that So we try to make the save the data in triples and saved it in like MapReduce for many machines to make it faster for them to search for the data using the Hadoop. Is
Okay.
that your question was?
Yes, madam. Madam, I have one question. Uh,
Yes.
Madam, so what is the important for Hadoop framework in your research?
Okay, at the beginning, this search was from 3 years. So I think that there is new solutions now in 2025. But in that time, the Hadoop was helping to for retrieving the RDF data quickly for the chemists.
Yes,
Hope,
okay.
yeah, hope that helped you. Question. Now there's new solutions rather than Hadoop for sure.
Thank you,
Okay,
ma'am.
ma'am. Okay.
So we'll be moving further. Up next, we have Palak Arora. She is presenting the paper title Evaluation of Hindi Sindhi Machine Translation System. Palak ma'am, are you there?
Yes, sir.
Okay, ma'am, you can start your presentation.
Good afternoon, everyone. I'm Palak Arora, and today I'm going to present our research paper on the topic Evaluation of Hindi Sindhi Machine Translation System. Is my screen visible?
Yes, ma'am, it's visible.
So, these are the table of contents. I'll start with the introduction, followed by literature review, experimental setup, results and discussions, then conclusion. Machine translation is a subfield of computational linguistics which is concerned with the automatic translation of text or speech from one language to another. There are various approaches to machine translation, like rule-based approach that relies on linguistic rules and grammar structures. Then a statistical approach that uses large bilingual corpus to generate probabilities. Then example-based approach that uses past translations to translate new data. Then neural-based approach that uses deep learning models to generate accurate translations. Despite having so many approaches, we need to evaluate the machine generated outputs. That is a very challenging process due to the complex structure of language. So, evaluation is a process of assessing the quality of machine generated outputs. Broadly, it can be divided into main types that are human evaluation and automatic evaluation. In human evaluation, we human beings can judge the quality of machine generated outputs. While in automatic evaluation, we used various matrices, automated matrices to access the quality of machine generated output like Blue, Meteor, TER, and so on. These are the papers that we have gone through while developing our system. Experimental setting. Initially, we have collected 1,000 sentences from PM India's official website. Then these sentences were translated into Sindhi Devanagari using various online available tools like AI for Bharat and Devanagari Translator. We have also translated these sentences through our developed statistical machine translation model. So this is the example of a few sentences. Like we have taken the Hindi sentence, then we have translated sentences by using AI for Bharat model and Devanagari translator, and the third column shows the results of our model. Then to evaluate the performance of these models, we have used certain matrices like Blue, Meteor, CHRF, and ER. Blue commutes precision over engrams and imposes a penalty for brevity. Meteor commutes the precision and recall of engrams considered synonyms. TR measures how many edits are needed to turn the machine translated text in reference translation. CHRF commutes the character levels clarity and precision, recall and depth measure. CHRF RF++ is an extension of CHRF that integrates word level precision and recall alongside character level engrams for enhanced evaluation. So these are the results of our collected data. So we have collected the scores. Initially, we have calculated the score for each sentences. Then we compute the average for each metric. So the first row shows the results of AI for Bharat model, then Devanagari translator, and third one shows the results of our developed model. So these are some of the examples, and these are the uh, uh, some of the errors that we have find while developing or while evaluating our systems. So we have seen that existing engines struggle with complex sentences, or they can generate grammatically incorrect translations. We have also observed that AI for Bharat omitted certain words while translating the source sentences. We have also seen that some models are performed poorly in handling numeric data. They are not capable to to translate decimal numbers. The model was also failed to translate months and days name. Also translated some words in English language only. So we have concluded that with the help of automated matrices, we conclude that a developed statistical machine translation model has shown good results as compared to other existing models for Sindhi Devanagari. These are the references. Thank you.
Yes, madam. I have one question regarding your research.
Yes, sir.
Madam, during this analysis point of view, and how can I classify for your error in your proposed model? Because in previously we have so many existing systems are available, right? We are going to convert it, we are going to translate it into some other languages. But how can I how can I analyze for your error in your proposed system? So how can I increase the quality?
So we can increase the quality. Actually, in Devanagari, no much model is present here because so many work has been done using the Perso-Arabic script only. So only two models are available, that are AI for Bharat and Devanagari translator. So we have a human evaluation. Actually, we have an ANRF sponsored project. This is the Hindi and vice versa machine translation system. In this project, we are developing an NMT system or SMT system to translate Hindi to Sindhi Devanagari and Sindhi Devanagari to Hindi. So while developing the model, we faced lots of error. We have human evaluators that can help us to identify the errors.
Okay, madam. Thank you. Thank you.
Okay.
Amit sir, do you have any questions?
Yes, one question from my side.
Yes, sir.
Uh, uh, which algorithm you have to use in your work? What is the performance, the best performance regarding your research work?
Sir, we are using a statistical model. We are calculating the probabilities using HMM, hidden Markov models.
And how to implement this model? You are implementing or not?
Sir, we are working in a team. So, sir has implemented this model.
See, the model has been implemented using hidden Markov model. It also has an A-star algorithm for generation of translations. Because when we have a target language translation that needs to be generated, so a translation letter is generated, and there algorithms like optimization algorithms like A-star, they help in planning a much better word over the other available words that are available in the lattices. Moreover, the system provides prediction, so it has a probability-based system for generating the fluent translations. So it is based on a 5-gram model where the probability of a word depends on the previous 4 occurrences of the words, and it has a translation model where the probability of the target word is captured based on the source word. So this translation model is multiplied with the probability of the language model, and some reordering model is also there, which is kind of a secret sauce for us. And then we have an argmax algorithm, which is kind of a decoder, which finds out the max probability among this computation, and then finally the best translation is selected.
Okay, sir.
Thank you, sir. Thank you, ma'am. So up next we have A.S. Lakshman. He's presenting the paper titled High Rate DDoS Protection in Cloud Computing Environment. Lakshman sir, are you there? Lakshman sir, are you there in the meeting? I guess he is not present. Moving further, next we again have Palak Arora. She is presenting implication of teaching a low resourced language through machine learning. Palak ma'am,
So
you can again proceed with your presentation.
I'll be presenting this paper on behalf of Polak. Let me
Okay,
share
sir.
my screen.
Okay, sir. You can share your screen. Just a second. Yeah, you can share your screen.
So generally, we use computer-aided language learning for teaching people who are not native of a particular language. And so this has been a technique that has been used to teach English as a second language in most of the institutions worldwide. And there have been efforts to teach a second language through one's native language or in a language that a person is more comfortable with using computational techniques. So here our effort is to teach kids who belong to Sindhi families, and due to cultural shift who have moved from now they don't speak, since their parents don't speak Sindhi at home, so these kids, they don't speak Sindhi at home, they don't understand Sindhi. So this poses a issue of language getting extinct. So using our machine translation system, we have developed a strategy to teach these kids Sindhi via Hindi system. So here we take call. So call is a technique where computers are used in teaching language. Generally, these are used in teaching foreign languages. If we look at the definition, so call is defined as the study that uses computer applications language education. It is an interactive teaching method that aids students in researching their language objectives. Machine translation can be one of the tools of teaching this language, this foreign language, because these machine translation systems, they have understanding of the source language and the target language. Source language being one's native language or the language which they are more conversant with, and the target language is the language in which the speakers are not so conversant, or they want to learn this language using the system. So our problem statement is again the same. We have kids who are from Sindhi families, but since like Sindhi population actually migrated from Sindh, Pakistan during partition, and over the years they settled in the Hindi-speaking belt of India. And so the people who migrated in 1947, they had a very strong roots with their native place. So they were very conversant with Hindi. Over the years, down the generation, people have stopped speaking Sindhi at home. So since one generation they have stopped speaking Sindhi at home, the next generation would be very much more less conversant with the language, and down the generations, at one point in time, the language would get extinct. And this is what we are facing with Sindhi right now. So, since the population had migrated into Hindi-speaking belt, most of the kids these days, they speak Hindi. They don't have an understanding of Sindhi, don't speak Sindhi at home, so they don't understand Sindhi. So, we used our machine translation system to teach these kids Sindhi. So, these are the literature surveys. Now, this is something. Call is something which has been there since ages. People have been researching in computer-aided language learning since 1990s. And in the recent years, some papers have also looked into how computational linguistics, natural language processing, or machine translation can be used in teaching a second language. So what we did was we initially looked at kids who are from these Sindhi families, and we select these kids from who had some cognitive understanding of a language, who had some understanding of the grammar system at school. They have been studying English grammar and Hindi grammar, so they have some understanding of how nouns, pronouns, how nouns are related to pronouns, how nouns are modified through adjectives, and so on and so forth. So we looked at that population and we selected some kids from age group from 11 to 14. And now, before starting this training of Sindhi to these kids, we gave them a questionnaire which was in Devanagari script, but then it was for Sindhi. So we asked certain questions for them, and they were asked to answer these systems. And then we introduced them to Sindhi. And so this was a 21 days workshop that we conducted. And there we introduced them Sindhi. And we also showed them our machine translation system. So this was the interface of our system. We asked them to put in certain words, which they certain words or phrases or sentences which they think is which they want to translate into Sindhi. Because if they want to converse with their grandparents, how would they do that? And since it is in Sindhi Devanagari, it is written in Devanagari script, so you can very well read out what has been written. So let's say we have a sentence called Jaipur Rajasthan ki Rajdhani hai, and the system translated it as Jaipur Rajasthan Rajya ki Rajdhani aahe. And when they were able to speak this with the grandparents, they were very happy because now the kids were conversing with them with the language that they used to love. So we first introduced them to this machine translation system. Parallelly, we introduced them with the Sindhi grammar system and what are the differences between Hindi and Sindhi. Where in Sindhi we have four different words. Like we have ja in Hindi, but then ja is written two different ways in Sindhi. Similarly, there are other characters as well, and they have their significance while speaking. So we introduced all these technicalities to these kids, and over time, uh, we then introduced them with our Sindhi to Hindi machine translation system. Then we asked them to put in certain Sindhi sentences, which which they use in their day-to-day life. And we asked them, what do you think would be the translation of the system? And once they came out with the translation, we used this automated system to generate a translation, and then we compared with their what they had translated. So this is how their understanding of the language improved over time. They understood where they were making mistakes, what at what particular point in time, which particular words should be used. Like Sindhi still uses some loan words from Arabic. So, but over time, since these people they migrated, like originally the people use the word capital. In Hindi, we call it Rajdhani. In Urdu, we call it riyasat. So the people who migrated from Sindh, Pakistan to the Indian part, to India in 1947, they used to call riyasat. But over time, since the language evolved, now people have accepted using Rajdhani. Now, this is a discussion that we had at length with National Council for Promotion of Sindhi Language. So they said that over the years, since the Sindhi population have intermingled with the Hindi population, so instead of using the Arabic loan words, now we use the Sanskrit loan words. So now, capital Rajdhani has been accepted as a word in Sindhi. So now, if I say Jaipur Rajasthan ki Rajdhani hai, so it gets translated into Jaipur Rajasthan ji Rajdhani aahe. Otherwise,
Sorry to
originally
interrupt
it
you,
would,
sir, but
yeah.
your 9 minutes over.
Okay. So what we did was we taught these kids this Sindhi. So these were those kids from the different age groups, and we marked we gave them certain evaluations, and we gave them some evaluation sheet to give us some understanding of how much Sindhi do they know. So this was their score before our 21 days workshop, and this was their score. Okay. So this was their score. So this is not before, but then this is after. So this was their score after the learning, and we had some 25 to 60% increase in the difference. So this was the average score across age groups. So after this 21 days workshop, all the kids in this age group, they were able to understand Sindhi, and they were able to roughly translate text in Sindhi, and had some conversation with the grandparents. So we developed our bidirectional machine translation system for Hindi, and we tested this with the students, with the kids, and the results show promising. We calculated, and so the score was in the beginning was just 42% average, and it improved after the 21 days workshop. It improved to 76%. So this was one study where we showed how machine translation can be used in teaching a second language. Uh, these are the references. Thank you. I'm open for questions.
Yes, sir. First of all, it's a very nice presentation, sir. Uh, Hello, sir. My voice is clear.
Yes, sir. Yes, sir. Please tell.
Yes, yes, yes. So actually, sir, in nowadays we have different type of mobile applications also there. We are going to converted Sindhi into to learning Sindhi through the Hindi script, like learn Sindhi
With
with Hindi script applications and learn Sindhi
hmm.
mobile applications. So many application is there. But what is the difference from your missing translation to other applications? So what is the
so
extra feature will be added here?
so these applications, like this Learn Sindhi application, we were part of this. This has been developed by National Council for Promotion of Sindhi Language. The problem with this application is that it has mostly static text. So it has certain predefined text that would be translated, that would be used to teach Sindhi. What we did was we gave a very in-depth, like ours was a semi-automated system where there were human teachers, there were human instructors who taught Sindhi at first. They taught the grammatical system, they taught the differences, and then at some stage in time, a machine translation system was used. So Learn Sindhi has only static text, predefined text that is there available with them, but there are machine translation system. You can give any text on the fly, and it would give you some Sindhi equivalent for that. So this is the major difference. R is a more dynamic system, whereas the text that is available, the systems that are available on Android apps or iPhone apps or web, they are more static. Plus, if you look at Google machine translation system or Bing machine translation system, so they don't translate text in Sindhi Devanagari, which is being spoken, because the kids are mostly based in Hindi speaking belt, so they are more conversant with the Devanagari script. The Google and Bing, what they do is they translate the text in Persian-Arabic script. So since the kids they don't know Persian-Arabic script, they for them the text is incomprehensible.
Okay, sir. Thank you. Thank you.
Thank you.
Amit sir, do you have any questions?
Sir, no question from my side.
Thank
Okay,
you.
sir. Thank you, sir. Thank you, sir, for your presentation. Moving further. Up next, we have Sadhvik Bathini. He is presenting integrating adaptive key points and CNN features for graph-based age estimation from facial image. Sadhvik, sir, are you there?
Yes, yes, I'm there. Can you hear me?
Okay. Sorry.
Can you hear me?
Yeah, sir. You're audible.
Okay.
Yeah, sir. You can share your screen.
So, hello, I'm Sadhvik Batini. I hope you can see my presentation. So, my name is Sadhvik Batini. Under Professor Debashish Samant sir from IIT Kharagpur, I would like to present my paper titled Integrating Adaptive Key Points and CNN Features from Graph-Based Age Estimation from Facial Image. So, a problem is simple. A problem is given a face image of a person, we need to estimate the age of that person. So we humans always do it. Like whenever we see a face, we extract gender, age, and lot more information from the face. And in 2022, Nature paper states that human performance in estimating age is much better than most currently available AI architectures. And age estimation has applications, like it has applications in computer vision, it has applications in human computer interaction, facial image analysis, and access control, and lot more. So we did a little literature on this, and I would like to present that. So it all started in 1999 when Korn used handcrafted features for estimating the age from face, and then further in 2014 and 9 they used convolution neural networks, and in 2022 they started using attention mechanisms, but recently they started using graph neural networks for better accuracy in estimating the age. So in 2023, Liu started using Simon's graph contrastive learning for semi-supervised learning, and Corbin used skeletal and facial key points for with temporal memory modules. And latest in 2025, Shaw used contrastive learning for with multiple triplet losses for improving the age estimation. And we found that there are some research gaps in this literature. So traditionally, the CNNs, which are used for estimating the age, are actually not utilizing the connectivity information between the facial key points. And we observe that the traditional facial key point extractors often extract same number of key points for frontal, left, and right profiles, which is causing self-occlusions. And the usage of raw pixel values as node features is also a limitation. So I will explain this in detail. I will explain these three in detail in upcoming slides so you can understand them better. So our methodology is that we have four modules. We first extract the key points, and then we form a graph using these two modules called graph connectivity module and node feature module. These matrices will be multiplied and a graph will be formed which go through graph convolution network, which actually has message passing and updating mechanisms, from which a node feature is average pool. Then we get an age by passing through fully connected layers. So we see the first part, adaptive facial key point estimation module. So in the left side, we can see in the top image that traditionally DLIB and retina face, normally they take 68 key points in every uh, facial image, every profile, like even it is a left profile, right profile, or a frontal profile. but there this is causing the occlusion. This is redundant and self-occluded points. So we use a separate model for dynamically selecting the key points so that we have 39 facial key points for left and right profiles and 68 for the frontal profile. So this will eliminate the redundancy and self-occlusion, and we can extract as much as good information from the face. So the next thing is existing methods often used raw pixels for their node features, which are not capturing the meaningful local patterns. So we crop a 32 by 32 patch around each facial key point, and then we used CNN blocks to filter out the patch and produce a high dimensional feature maps by which we flatten the feature vector as a node feature. Then for graph connectivity, we used the algorithm which is based on a triangular algorithm. The algorithm is given here, and it basically is checking if the triangles are formed and if the point lies in circumcircle and updates the connection. So you can see in figure 4 that how the graph is formed by connecting the points in a triangular fashion. So after constructing the graph, we pass it to two graph convolution layers. The nodes get updated and undergo average pooling, resulting in a single feature vector for the graph. The feature vector passes through the fully connected layer and thus producing the edge as a continuous value. We did experiments. We used subject exclusive protocol, and we split the dataset in 60% for training, 20 for model selection, and 20 for testing. We used Adam Optimizer and learning rate. So primarily we used four datasets, but specially we used HDB as our main dataset for training and testing. I would like to share the results. So in the left side, we can see that the cross dataset generalization results, that to verify the generalizability, we trained we trained our model on HDB dataset, and we tested on the other datasets. And in the right side, we can see that mean absolute error, we used it to compare with existing models. And this is the some of the model's predictions. And we can see that the ground truth as here and predicted age for some of the pictures in our test set. Thank you.
Yes.
One question
I have
from
a
my side. Yes.
Yes, sir.
How do adapt to the key point improve the accuracy of age estimation compared to traditional feature? You have to discuss about traditional feature you have to use in this research. So how do adapt the key points to improve the accuracy?
So normally the traditional way is that the key points are same for every view. Like for the left view, right view, we are taking the same key points so that the redundancy and self occlusion is happening, which is redundant for the age estimation. So we are using adaptive key points so that we can extract only the relevant information, not any incorrect or redundant information.
Why you are not using CNN model for this work?
We are using CNN model, but only for extracting features. Like not as CNN model, we are not using it globally because it is not able to uh, make the use of the connectivity information between the facial key points.
Yeah.
Actually, my question is, while we are constructing the graph with the help of the facial key points, what type of algorithm we are going to use?
While constructing the graph, the connections, we used an algorithm which is a triangle based. Basically, the triangle is constructed with the points, and then if the point lies inside a triangle, it is basically a mesh algorithm.
Okay. But is there any maximum thresholds are mentioned while we are constructing the graph? Whether we can say that it is a quality graph, and what is the threshold value we are going to use here?
Uh, We don't really use any threshold value, sir.
Okay. But how can I say that the particular graphics comes under all based on the all facial key points? How can I say that it's a quality graph?
So the graph is, if they are triangles, so the triangles are constructed. It is not about the quality. So basically, the triangles are constructed. So there is no need for thresholding and thing. Every point has the triangles will be constructed.
Okay. Okay. Okay.
Okay,
Thank you, sir.
thank you.
Moving further, next presentation is presented by Sunenori Inakura. He is presenting new method of construct a database using text generation AI. Sir, are you there?
Sorry, I cannot share my screen.
Just a second, sir. Just a second. Let me stop my screen sharing. Yeah, now you can share your screen.
Okay.
Yeah, sir, it's visible.
Okay. Yep.
You can start.
Okay. I'm Inakura from Institute of Science Tokyo. I talk on a new method to construct a database using text generation AI. So the institute research analyze various data on education, research, finance, and so on. These data are stored in the data warehouse, which is built by migration data from operational databases used in various departments. However, operational databases are individually designed, so requires the expert to handle data migration to data warehouse. This hinders data integrity for data migration, making it difficult to ensure accurate and reliable data analysis. One solution is a categorical database with ontology log. Categorical database, which is based on the category theory, a branch of mathematics, ensures the data integrity for data migrations. Also, ontology log oral express database schema intuitively, so in natural language. However, there is a problem. Through the data migration, multi-data references looks to be integrated to a single data reference. So it is quite difficult to clarify which is the most appropriate data reference. Then we leverage text generation AI, still in dealing with natural language for this problem. Okay, the category database, the database satisfying these conditions. And the category database ensures the data integrity for data migration automatically. In this presentation, we do not focus on the how to construct the category database. Instead, we focus on its methodology. So we skip these detail of these conditions. This is a course management database schema, and the problem is on the data migration. This is a database. It is converted to the data warehouse, something like that, by the data migrations. Here, let's pick up the data reference grade to country in data warehouse. In the database, there are two passes from grade to country. One is grade to instructor and instructor to country. The other is grade to student, student to country. There are two passes related to the grade to countries. But from only the data warehouses, it's quite difficult to judge which is the appropriate in two passes for this data references. So it's a desire to judge automatically which pass is appropriate in databases. This is a problem. So to this end, ontology log is useful. The ontology log describes the concept and the relationship in natural language, making the relation easy to understand. Please note that all log forms a category, and this is a database schema expressed in all log. in the log, the relation between the grade and student is described as a grade is awarded to student in sentence. So all relationships are expressed in sentences. In all logs, any successive foreign key or successive sentences are composite into a single foreign key or single sentences that carries the same meaning and interpretations. This is directly connected to the data migration, in which the data reference along the sequence are accurate. For example, the successive foreign keys grade is awarded to the student, and student is belong to the department. This successive sequence sentences can be composed into a single foreign key. Grade is an educational outcome of department, with implicitly including the concept of the student. So the successive sentence grade is awarded to student, and student belong to department, and grade is an educational outcome of department have the same meaning or interpretation. This is equivalent to the data reference grade to department is accurate compared to the successive data reference grade to student and the department. So now we evaluate accuracy of data reference in natural language. So we judge that the grade is department, the reference is accurate compared to the grade to student to department using by reading the sentence and compare its meaning and interpretations. So for this purpose, we can leverage the text generation AI using natural language. This is what we did. Okay, for the text generation AI for composite foreign keys, as a preparation, firstly, we instructed ChatGPT to respond an expert in category theory and database. Second, we provided some papers, these papers, and requested detailed explanation of their contents. Whenever the explanation was insufficient, we asked a follow-up question to refine the generated response. Third, we presented the database schema, this one, and explain the overall structure of the database, the role of each table, and the relationships presented by individual foreign keys. Fourth, to demonstrate the process of composing foreign key sequence into a single sentence, we provide the example: grade is awarded to student and student belong to department. A grade is an educational outcome of department. After these preparations, we instructed ChatGPT to generate 3 candidate sentences for each sequence of foreign keys and provide explanation for each sentence. For example, this is a response of the ChatGPT for the grade to student to countries. So this passes. The ChatGPT generates a sentence, 3 sentences generated. First, grade indicate countries of the student who receives. Second, grades are associated with country of the student. Third, grades are identifying the country of the students. So ChatGPT produced candidate sentence quickly. The interest point is what sentence is the most appropriate, but it depends on the database design judgment. So we do not judge what is the best. But anyway, ChatGPT produced a candidate sentence quickly for this path, grade to student, student to country. On the other hand, ChatGPT does not generate a sentence for the grade to instructor, instructor to country, this path. The ChatGPT response is that this sequence of foreign key may not have a meaningful interpretation in the data structure. The reason is there is no clear causal or semantic connection between the grade and instructors' nationalities, making it difficult to justify linking them through a composite arrow in terms of data structure. So ChatGPT point out that data reference grade to instructor country is not appropriate in the database. So the text generation AI generates meaning of this path grade is to student country, and also text generation AI point out the difficulty to find the meaning of the grade to instructor to country. So
Sorry to interrupt you, sir. Your 9 minutes are over.
thank you. So this means that the pass grade is awarded to student. Student is from country in the database is appropriate. The data reference grade to country in data warehouses. So we can see this path is appropriate in data warehouse. By developing this furthermore, we can leverage the text generation AI to find meaning of the long successive data reference and to find meaningless data reference in large database. Takeaways. Text generation AI is useful for evaluating accuracy of the successive data reference in database with natural language. That's all. Thank you.
Sir, do you have any questions?
What do you validate the accuracy and consistency of AI generated data?
Oh, so, okay. In this scheme, we judge the accuracy by comparing its meaning, so it is difficult to evaluate quantitatively. But the data reference, data integrity itself is automatically ensured because we use a database, a categorical database. So data integrity itself is automatically ensured, but so problem is what path is appropriate. It is judged by compare its meaning, the meaning which is good or not.
Jagdishan, sir, do you have any questions?
No, sir. Thank you. No, sir.
Thank you, sir.
No, sir.
Okay, sir. Thanks, sir. Up next, we have Akhil Sadiq. He's presenting the paper title Soul Charger Bot, a AI-driven emotional champion for Gen Z challenges using LLM AMA2 and QLARA. Akhil, sir, are you there?
Am I audible, sir?
Okay, sir. Yeah, you are audible. You can present your screen, sir.
My screen is visible now.
Yes, sir, it's visible.
So a warm afternoon to everyone present here. So I'm Akhil Sadiq from a team of 7 members. So we are from Sona College of Technology, Salem, Tamil Nadu, India. So every problem, every project has its own story. So like that, our project has our own story. So I'm a final year student. So for a span of 4 years, we have a lot of friends. And in common, most of the friends face 4 different problems that causes major stress and depression in their life. So mostly it will be like love failures or academic arrears, placement setbacks, or some financial difficulties. So these are the common problems faced by the student around us. So we thought of why don't we solve the problem specifically in our college or specifically for the students in IT field or CSE field, so that it could bring drastic change in their lives as well as in the society, as well as to the advancement of college and the people around them. So for that, we have created Soul Changer Bot, an AI-powered emotional companion providing personalized empathetic guidance to the students. So, as I mentioned earlier, there are some current alternatives which are helping people generally, not specifically for the students. So we are focusing on niche specific only for the college students facing those issues. So currently Replica is there, but it's quite so might charge some dollars to help you. And that too, it's not so much personalized, it's quite personalized to the student. And also, as I mentioned, these are major problems faced by students. So we are solving this issue by fine-tuning the Llama 2 with the Clara technique, so that we can also add some personalization techniques like dynamic prompt system kind of things. So with the help of that, we can provide more personalized queries or responses or help to the students who are facing these kind of issues. So, and also it's quite cheaper compared to those alternatives. And as this is an initiative, we can initially provide it for college students from college management. They will have the support to, they can easily support with the computation powers for building these kind of applications. And speaking technically, so we had utilized Llama 3 to 7 billion parameter model. Also, we had utilized Clara technique to fine tune it. So we can easily fine tune somewhere around 300 million parameters easily. And we had fine tuned it with 4-bit quantization on T4 GPU. So due to some lack of resources, we had utilized Colab T4 GPU. So it had performed really well. While fine-tuning process, these are our parameters and metrics that we had used to fine-tune the model. So we had utilized Llama to 7 billion parameter model, and the learning rate we had utilized to be 4. And we had fine-tuned for 10 epochs and for sequencing of 2048. And also quantization, we had utilized 4-bit quantization. And the initial loss was somewhere around 2.68, more than that. The final loss was quite good. It given somewhere around accuracy of 70 to 80%, depending on the various use cases. And for fine-tuning our project with Clara, we need to create a custom data set. For that, we had utilized some emotional support forums and kind of general problems faced by students and people. And we had sourced the data from resources like Reddit or some other platforms like mental health suggestion platforms, also Khan Academy, and some also from Medium and TEDx talks, so that we can provide more change to the students. As well as we are utilized reinforcement learning from human feedback, so that it will keep on improving itself, so that it can help the people who are making use of it. So this is how our flowchart will looks like. So initially, a user will give an input, and our Llama fine-tune with custom data set, which is scrapped from various websites. And after Clara fine-tuning, we are using Colab T4 with as an inference at present due to lack of some resources. And then it will give it personalized responses based on the previous prompts that we had asked. Let's say, as you know, ChatGPT, it will provide responses based on the previous prompts, like which we had make use of them. So, and then the feedback based result will be there, and the database will have the previous prompts, and the responses will be similar to that. And the final output, the user will get satisfied or some issues they face. In current alternatives, these are the some of problems, and Soul Changer bot will easily tackle all these issues, like Gen Z personalization, specifically for Gen Z students who are somewhere around at present 18 to 21. So these are our target customers, and we are going to solve only the problems faced by these students and not more than that. And also it has more cultural relevances. It can easily help students with arrears, fees issues, friendly conversational tone. It's quite more personalized application. And also we can also help with custom academic support, also emotional support. And it is available 24/7. The current alternative is quite expensive, and it is quite limited to the which means it can satisfy all wide range of audience, but not a specific range of audience like student like facing these kind of issues. And what we had achieved is that, so with the help of this application, the student can easily chat with that. They can share their feelings like that. Most students face loneliness, and they find it difficult to share their problems with their family or to the friends. So they can share the problem to our bot, and our bot will easily help them to overcome their stress and make them feel confident, and they can somehow give them confidence to solve their problem easily. And also it gives some more emotional and so much connected responses. So the key takeaway is that it helps people reflect on their feelings, and also give some quotes to make them feel so confident. And technologically, you can support people to come out of their problems and depression states. And these are some of the references that we had took. That's it. Thank you for listening to me. Now I'm open for your questions.
What method did you use to evaluate the bot for emotional intelligence?
Yes, sir. Sir, generally, most of our Llama model has the capability to understand what kind of emotional state the person is speaking now. And also, based on some keywords, we can easily identify what kind of emotional state the person is now. So with that, we had found the emotional situation of the person, and we are solving with Llama.
Yes, sir. I have one question regarding your
Yes, sir.
project. Sir, actually, it
Yes,
have different AI digital tools are available, like empathy AI and virtual therapist and AI journaling combines emotional support for virtual assistants. So many AI
yes,
tools are available to find out emotional companion.
yes,
And
sir.
according to your project, what is the deviation? What is the extra performance are available in your application, sir?
Yes, sir. So talking to that, we are focusing only on the four main problems, because that's the major problem faced by the students, which is financial problem faced by the students, and also academic areas causing them stress, and also their love failure kind of problems happen during their times, and some other family issues that they face. So we fine tune based on the data that we scrapped from various resources only to solve these four problems faced by the students. That too between the age of 18 to 21 who are pursuing their college, probably a first year or second year student. And also, let's say if some cases, a student has some financial issues, he want to get rid of the financial issues and he want to grow in their life. So we will give some suggestion and advices. If you can freelance some kind of software development or video editing kind of some things, so that you can solve your financial problems. So likewise, we'll provide some tailored and personalized advice to the students specifically. So that's what makes us unique from others.
Uh, it's all the data are gathered from your real-time kind of, right?
Yes, sir.
Hello. Yes. So how can I gathering the information, sir? So because you have four different situation. One for career based, another one is like love failure. How can I gathering the information? What is the size of your data sets?
Yes, sir. Okay, sir. Sir, currently we have 2000 rows of data sets scrapped from various stores like Reddit uh, and some other platforms like Medium talks, like psychiatrists, how they actually helped students to overcome these kind of issues. So these are the sources that we collected data, and also our professor helped us to get the data, like some inspirational stories. Let's say our college senior who faced these issues. At present, he is working in X company with a good salary, with a good lifestyle. So we can show this as an inspiration to the junior who is facing the same issues. And also you can connect with the senior, so that we can easily solve their issue. So this is what is source of our data and features that we provide.
Okay, sir. Thank you.
Thank you, sir.
Thank you, sir, for the presentation. Okay, so before moving further, let's just call the presenters who are absent. Urvi Kolawala, are you present, ma'am? Urvi Kolawala.
Yes, sir, I'm present.
Okay, ma'am. You can present your screen, ma'am.
Yes. Sir, it is visible?
Yes, ma'am, it's visible. You can start.
Good afternoon to everyone. My name is Urvi Pullawala, and I am presenting on behalf of myself and my co-author, that is Veena Jogakar, from the Department of ICT from the Veer Nirmat South Gujarat University. Our presentation today is titled a proposed framework for insurance service blockchain DApp. Our research that introduced a novel decentralized approach to ensure to insurance service process using the blockchain technology. Talking about the abstract, the financial sector faces the several challenges that includes inefficiency in claim processing, then lack of transparency, and a high dependency on intermediaries. This challenges leads to increasing operational costs that delay the settlements, that whatever the claim they have done, that delay is getting. And additionally, the fragmented data management, interoperability issues, and it's regulate the requirement, the further the sector is efficiently involved over here. This factor not only impact the customer trust, but limits the ability of the insurance to adapt that revolving matter that demanded. Our research paper explored the potential of blockchain technology in addressing this challenges that we have seen. Our proposed work aim to use blockchain offers that decentralization with that transparency that we have with the blockchain, and tamper-proof system for the claim management in this sector. Financial service that provides the phases that increase the operational cost, that is demanding customer also, and the increasing the competition also. This establish the insurance to age due to the long-term customer trust also, and the market experience also. By that, they will get the proper experience. The insurance industry is shifting to the digital mode to improve the transparency to the customer, or they have the parties, efficiency and customer experience. The current issue we have is in industry sector, that is identity validation, security, the proper security is not there, quick processing for claim, particular claim, and the trust throughout the financial service process from the initiation to the claim settlement also. The financial organization rely on the central authority for the system maintenance and the transaction security. Over here, in our this paper, we have introduced that blockchain is the best solution for this scalability and the reliability and the transparency of the in the current issue. We have we have not the transparency. Over here we can resolve this issue. The blockchain is distributed database or ledger known as a blockchain is shared by thousands of computers worldwide. It keeps track on every expanding list of records that is known as a block. This network is made possible by the interconnected computer that is known as nodes. Over here, we have used that consensus. Consensus is the protocol that is essential for agreeing all the blocks of the transaction, ensuring all the participants, that is all the network member that sharing the same view, then and then only the agreement will get further. Next technology we have seen that this smart contract is a computer program that consisting as a service rule that runs on a particular blockchain only. It executes automatically when the predetermined condition gets true in the terms of made by the entity. Over here, the smart contract are the core component of the blockchain technology. The next we have the IPFS. IPFS is that file system that is store all the shared file and it can easily store whatever the file we have. That is in decentralized file storage system that works with the blockchain technology only. This large file can be efficiently stored over here also. Then we have talked about the IPNS. IPNS is an naming system that decentralizes the naming system that allows you to associate the name with their content if it is dynamically changing the file. Over here the file is to be dynamically changed over here. IPNS is a part of IPFS only, that ecosystem, and uses the public key infrastructure over here. Now this is the possible solution. It's have the different solution, but we have seen this possible solution that improving claim processing and reducing reliance on the intermediary that can cut delay. That if someone have claimed something and the delay is going on over here, it will not possible for the delay. Lower cost and reduce the malpractices also. Blockchain can revolutionize insurance by speeding up the claims, enhancing the transparency by using this blockchain. Then if the fraud is going on, it will get detected also if multiple times the claim is going on. By that, this is the possible way that we can stop that. A distributed network that use the consensus algorithm to agree on a value and verify that particular transaction. If all the networks are agreed to on one particular values, then only this consensus is used. Over here, the literature review. The author Castro have used this hybrid consensus model. In that, he had used the POW consensus and POS. Over here, they have provide the POW, that power of that is the proof of power that provides a strong security, and in POS that offers the energy efficiency. Together, they aim to balance the security and scalability by using both. That is the hybrid model. And over here, they have the limitation as hybrid model that increase the operational complexity and introduce the security trades off. Now, the second author, Zank, have introduced that sharding phase cross shared communication that issues and potential security and their vulnerabilities. Next is
Sorry to interrupt you, ma'am, but your 9 minutes are over.
okay, sir. Let's move towards the like a research gap. Whatever I have research over here. The research gap, the main research gap is have lack of unified integration of blockchain with the IPFS and IPNS. And the second, we have find that absence of use case specific consensus. The whatever the consensus they have used in my work, no work that process the consensus mechanism that tell the specific need and risk of profile for the insurance application over here. In my proposed work, I have proposed a research that integrating blockchain with the help of IPFS and IPNS, that introducing the insurance specific consensus protocol that have the smart contract for the scalability purpose and the fraud resistance. Decentralized insurance processing directly addresses the limitation in existing literatures. This approach offers a novel, secure, and regulatory compliant architecture that has not been explored, establishing a clear research gap and need for the evaluation. This is my flow chart, that particular model over here. I have used the IPNS and IPFS. Over here, we have two process. The first one, for the customer need to register for the insurance first of all, registration of insurance should be there. The second step is organization. As soon as the form is filled, the organization physically verify the proposed detail submitted by the proposal. And this third step, that proposal is approved, the insurance is issued to the customer. That insurance will get issued. In over here, the issued insurance detail are stored in decentralized storage system, that is in IPFS and IPNS. Over here, if the insurance term is 1 year, if the insurance term is 1 year, then it store all the file details in IPFS. And if the insurance term is more than 1 year, the details is stored in IPNS. Why in IPNS? In IPNS, we can dynamically change our file, but in IPFS, we cannot able to change our file, or we cannot modify it over here. If it is the last term, if the insurance is in last term, the final policy data is stored according to the terms whatever the customer have done. The next process we have is claim. In claim, the first of all, the customer will claim for the process. The customer register a claim request in case of insurance claim event. The second step over here is the TPP over here, that physically verify the claim, whether the accident is currently occur or not. That verifies the claim details by conducting an in-person audit for the treatment records. Then after, the verified claim data is stored in this particular IPFS and IPNS for the transparency and security. The smart contract mechanism is executed over here. And then the blockchain to validate the claim request, blockchain will validate that particular claim, that the claim should be given or not. That is in our smart contract. Upon the successful validation of by the consensus, the claim is executed, the necessary transaction whatever we have. These are the steps that I have already explained over here. For the conclusion, to ensure the main thing is we are ensuring the security over here, efficient data sharing, immutability, accurate record keeping and data verification, and minimal delay by any stage of the process. There over here there is no file work is there, so it get the minimum delay by the stage of any of the process. Then fast or instant process is going on, flawless issuance and claiming process is going on over here. These are the references that I have taken, and thank you for the giving the time, and I am open for the question.
How does your framework handle scalability and transaction throughput, especially during the high volume of insurance claim process?
Sir, can you please repeat it?
I am asking a simple question. How does your framework handle the scalability and transaction throughput, especially during the high volume of insurance claim process?
Over here, the scalability that done in blockchain only, that's why that's why we are using the blockchain, and in that blockchain the smart contract and consensus that we are integrating, that new consensus, that model is that IPNSFS, the blockchain that we are thinking about the creating the particular that model.
Yeah.
Sir, my side is there is no question. Thank you.
Okay, thank you, ma'am, for the presentation.
Thank you, sir.
by A.S. Lakshman. He is presenting high rate DDoS protection in cloud computing environment. A.S. Lakshman, sir, are you there?
Yes.
Okay, sir, you can start your presentation.
Yeah. So, good afternoon, everyone. I am A.S. Lakshman Babu, and I'm honored to present my research on high-rate DDoS protection in cloud computing environment at ICTIS 2025 conference. So, this work addresses the critical and growing challenge of securing cloud service against increasingly sophisticated DDoS attacks. Speaking about the DDoS attack aims to exhaust system resources and make services inaccessible. These attacks range from brute force traffic flood to stealthy low-rate attacks. With the rise of cloud computing, due to its scalability and flexibility and cost effectiveness, cloud environments have become attractive yet vulnerable targets. So, and while a variety of defense mechanism has already been implemented, like filtering or rate limiting or some overlay networks have been proposed, but they are helping them at some minimal extent. But for real time, they are very vulnerable for these attacks. So these growing threat landscapes call for a new DDoS protection model that will be scalable, cost effective, and also dynamic for all range of DDoS attacks. So this is the problem statement. Like the traditional DDoS mechanism is mostly focused on rate limiting and traffic filtering. So if we are doing that, then there are cases that both the legitimate traffic and attack traffic will be affected. So it will also leads to the business loss in business reputation. So it will also damage the user experience also. And it is practical for small to medium cloud service providers to maintain this a good DDoS defense mechanism. So we are focusing on a real-time, scalable, and cost-efficient defense mechanism, which can be dynamic and adaptable for all type of cloud environments. So, like, let's take a real-world example. During 2019, there was an attack of HTTP2 rapid reset vulnerability, which caused over 398 million requests per second. And some of the major cloud providers were one of the victims of that attack, such as Google, Amazon, Cloudflare, and they have seen a never ever huge hit of request during that time period. So the main working of that DDoS attack was that attackers used to send the HTTP request, and immediately they would either reset it or cancel it. So that made the server overwhelming and overburdening. So existing rate limiting techniques were not help that also affected the legitimate users from using their services. So this was the the graph that was hit during the vulnerable attack, DDoS attack. So these are some of the related works that I've worked on DDoS attack for protection in cloud. So in the first paper, they have been they have discussed the topics related to the defense mechanism, such as software defined cloud or focusing on ICMP and sync flooding attacks. So, but there are no any proper detailed implementation on how to do it, how to prevent or how to detect or mitigate the DDoS attack. So similarly, somehow some paper have used with time analysis or geolocation, but we can nowadays the advanced technology has been more advanced that the location has been changing within few seconds by using rotational proxies. So some of the similar research have been done on the same system. So what methodology we are proposing is that initially we will be creating there are two scenarios. Basically, there are two scenarios. First one will be normal scenario where user will be requesting any target endpoint, and the logs and the activity will be monitored by Splunk. If no any suspicious activity is detected, then the request will be directly forwarded to the target server. But if any traffic spike is detected by the Splunk, then the Splunk will activate a sandbox environment And after activating the sandbox environment, we will be activating a captcha server, validation server, where if any user is accessing a website, he must go through the captcha challenge. If the captcha challenge is solved, then only he will be redirected to the endpoint that he wants to visit. Otherwise, his request will be blocked. If while solving the captcha, if any multiple requests are coming from the same IP, then that IP will be quarantined for 15 minutes. So what this does is that like this will during the attack scenario, this will allow legitimate traffic to access the website. At the same time, it will also help in rate limiting the server. And when the sandbox environment will be activated, we'll be also using blacklist IPs from open source intelligence. And if any IPs are matching with the blacklist IPs, then they will be directly denied. This will also help in this will also not overwhelming of the server. So this is the system architecture of the system. And like these are the comparative analysis of a proposed system with the existing. Like our method, the proposed system that we have approached here is we have used Splunk and behavioral analysis for the detection. And what normal traditional people use are like static rate thresholds or traffic distribution. They use load balancer to distribute the traffic. And for high accuracy, we have used captcha and sandbox validation. And some people may block the request, which I mentioned that already, that legitimate user may get affected due to it. So similar, and of also effectiveness against botnets. So due to captcha, it is like mostly not feasible for bots to solve the captcha. So it will stop even if botnets are attacking the server. And low and other systems are lacking this approach. So these are the future scope. What we are planning for the future is that we will be focusing on stealthy attacks, also low rate attacks. So that can where we will be implementing anomaly detection and AI driven predictive models also in it. And and these are the conclusion of our proposed system, that there are critical gap in current DDoS protection system, where they only apply rate limiting factors or any very cliche features that can be applied to protect their system, but it also affects the legitimate user and make them loss in business reputation. So approaching this proposed system may help them in real time for some extent. Thank you. And these are the references that we have used for our paper.
Yes, sir. So actually, I have one question.
Yes, sir.
Sir, in your proposed system, you are going to use one IP reputation check, right?
Yes, sir. Yes, sir.
In the IP reputation check, and which time period, what is the deadline we are going to update it for IP table? That means Internet Protocol table. What is the limitation will be there? Any timer has been set?
Yes, if within 4 seconds, if more than 10 requests are sent from a single IP address, then that IP will be quarantined for 15 minutes. Because for a normal human, it is not possible to send 10 requests within 4 seconds. So for and that will be only applicable during the sandbox environment, when the alert system is active. During normal period, there is no any rules protocols followed that to make to make the user experience very feasible.
Yes, sir. One more question, sir. Actually, while we are sending the information, how can I protect your information to the another user? Any security algorithm or security protocol are used in the destination point?
We can we are not mostly focusing on, currently we are not focused on securing the packets. We have just focused on the protection, mitigation and detection of DDoS attacks.
So, but in the security point of view, that one encryption concept we are going to use while we are presenting this, like TLS and one more encryption process are done in for how
Yes,
can I protect my informations?
so like we will be using the HTTPS protocol for the proxy server, which will verify both the sender and which will verify the receiver, so that it can be easy for us to detect the botnets. So usually botnets are not certified, so it can be easy for proxy server to detect which are the like HTTP request and HTTPS requests. So if HTTP requests are coming in bulk, then then also we can activate the sandbox environment.
Yes, sir. Actually, as of now, in your proposed work is like this application has been implemented in the cloud computing point of view, right?
Yes, sir.
So, what about your future work, sir? And where we are going to expand it here?
So we will be building a system framework which can be which will be open source and adaptable for all types of cloud service, and which can be utilized by small and medium level organizations also, because it is not affordable for them to adapt for proper DDoS protection system due to some budget constraints. So we will be focusing on making a open source system of generalized framework and providing them, and also we'll be focusing on low rate attacks, because nowadays low rate attacks are also more vulnerable as compared to high rate attacks.
Okay, sir. Thank you. Thank you.
Yes, thank you, sir.
Amit sir, do you have any questions?
No question from my side.
Okay, sir. Thank you, sir, for presentation.
Thank you.
Doha ma'am, are you ready? Your mic is working properly now?
Hello everyone, I hope you are
Yeah,
here.
yeah, you're audible now. You can start your presentation.
Okay. Is it clear?
Yeah, ma'am, it's visible.
Okay, my name is Durham Helhen. I'm a master's student at Basra University in Iraq. My paper talking about a survey on advancement in EMG hand gesture recognition. Let's first of all define what is EMG and what is hand gesture recognition. EMG is electromyography signal that records the electrical activity produced by skeletal muscles. It's used in biomedical engineering, prosthetic rehabilitation, and human-computer interaction as well. And hand gesture recognition refer to the ability of the computer or device to interpret and understand human gesture. It's important to control the prosthetic limbs and robotic hand. It's also used in various applications such as gaming, virtual reality, and robotics. My paper is a review. So what this review cover? It's cover the EMG hand gesture recognition stages and the discussion and comparison between the authors at each single stage. It also discuss the challenges in real-time hand gesture recognition. So the basic stages of hand gesture model is, first of all, data collection to collect the EMG data, and then data pre-processing to pre-process them and remove the noises. After that, data segmentation to segment the EMG signal, and feature extraction to extract the feature manually or automatically, and the last stage is classify each gesture. Let's start with the first stage, which is data collection. To collect the EMG signal from the amputees, we use a sensor that is called electrode. This electrode should be placed on the forearm and on the muscle that are responsible for the hand movement, because correct placement is crucial for the accurate recognition as shown in those two pictures. The EMG signal can be recorded in two ways, and the first one is intramuscular EMG, which is involving inserting a needle of electrode into the muscle. It's precise, but it's make pain and discomfort, so it's not preferred by the patient. And the second one, which is more common and more practical, it's the surface EMG, which is non-invasive method that record the muscle activity from the surface of the skin by using one or more electrode. And this picture show the myo armband, which is type of surface EMG electrode. The next stage is pre-processing, which is important stage to enhance the quality of an EMG signal, because sometimes the EMG signal, it could conflated with various external signals such as electrical interference and motion artifact, which cause a noise to the EMG signal. And to pre-process them, we use a filter to remove the noise and normalization. And this table show some type of filters and frequency ranges that have been used by different authors. The next stage is segmentation or windowing, which is involved dividing EMG signal into windows and that has the gesture activity. It's helped to isolate the useful data for more accurate feature extraction and classification. And we have two windowing approaches. We have overlapping and non-overlapping. For non-overlapping window, the EMG signal will segment into different segments and process each segment individually. It's faster, but it might miss some information. And for overlapping window, it will also segment the windows into a segment and allow each segment to partially share data with the other segment. It will improve the accuracy because it will help to capture more signal details. And the next stage is feature extraction, which is a process of selecting a key pattern like signal strength, frequency, or a shape that make each gesture unique. And these feature then will use by machine learning or deep learning technique to recognize each gesture. There are four types of features. First one, time domain features that use the raw signal. It's simple, fast, and good for real-time system, but it's sensitive to the noise because it used the raw signal, which is mean EMG signal before pre-processing. And number two, frequency domain features that analyze the frequency, the changes in the frequency ranges, and it's require more computation, so it's not ideal for real time. And time frequency domain features, which combine both time and frequency features. It's provide a rich information, and it's ideal for dynamic gesture, but it's computationally heavy and harder to implement in real time because it takes time. And the last thing is spatial features that use the relationship between multiple EMG channels, and also it requires multiple channel and more processing. And then the final stage is a classification. I mentioned that my paper is a review, and most of papers that mention in this review, they have used two type of classification method, which are machine learning and deep learning. Each one of them have different method. Machine learning is simpler and faster for small data sets, but it uses manually feature extraction, and it cannot capture the complex pattern, while deep learning, it uses automatically feature extraction, and it can capture and recognize the complex pattern, but it requires a huge data and it's computationally cost. And also mention that in real time hand gesture recognition using EMG signal, there are some challenges. Some of them is the comfort and appearance, because it's pain and there's a skin issue, and also it's a natural look because it's different than the real arm or real hand. And to the function, It's limited movement, heavy and low battery. Also, it's high cost. Usually, it starts from $1,500. It's hard to control them, so they need training, and training need processing, and processing take a delay, which affect the real time. And also EMG interference, that it may interference with other signal that make a noise. For example, the electrode signals, and also when the patient
Sorry
movement.
to interrupt you, ma'am, but your 9 minutes are over.
Yeah, I'm about to finish it. And also the amputee movement, the signal, it will vary when the amputee is sitting or walking. And at least we can conclude that this paper provides a comparative review of SEMG signal based on hand gesture recognition. It outlined the key stages, including detecting the signal using non-invasive devices, and then pre-processing and filtering. And for segmentation, they have been used different segments, and we should pay attention that the segment should not be too small because it will not have enough information, and also it can't be too large because it will cause a delay. And also it mentioned the four type of the features, and the machine learning and deep learning method for gesture classification and comparatives between their accuracies. And also this paper highlighted the SEMG signal precision, that it's influenced by different factors like muscle contraction, the electrode placement, and the electrode skin contact quality. Thank you for listening, and if you have any question. You hear me?
Yeah, you're audible. Jagdishan sir, do you have any questions?
Sir, no, sir. Thank you.
Okay, sir. Amit sir, do you have any questions?
No, sir. Thank you.
Okay, ma'am. Thank you for the presentation. Up next, we have one more presentation.
Thank you for listening.
Okay, ma'am. So I sincerely thank everyone, our authors, and excellent presentations and contribution in this session, and all our participants to be a part of international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 10th session and the previous nine sessions. We will be happy to have you in 11th session in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I thank our session chair, Dr. Amit Sharma, for chairing the session. A token of appreciation to chair on the behalf of ICTIS 2025 and Global Knowledge Resource Foundation and partners. I also thank our second chair for the session, Mr. Professor Jagdishan Srinivasan, for chairing the session. A token of appreciation to the chair on behalf of Team ICTIS 2025 and Global Knowledge Research Foundation and partners. Sir, do you have any closing remarks?
No, sir. Thank you. Thank you very much for your opportunity to express our knowledge to all the presenters. And thank you for your opportunity, sir. Thank you.
Yes, sir. Amit, sir, do you have any closing remarks?
Thank you, sir. Thank you, sir. Thank you for such kind of opportunity to provide me in the joining international conference. So thank you, and thank you all presenters, and thank you for the conference team.
Sir, one
Okay.
more compliment, sir. Actually, in the certificate of appreciation, instead of professor, you can mention doctor. Okay.
Okay, sir.
Yes,
Thank
sir.
you, sir.
Yes, sir.
We'll
Thank
make
you.
the
Thank you.
changes.
Yes, sir. Thank you.
Okay, sir. I kindly request you all to switch on the cameras for the quick snapshot.
Yes, sir. Yes, sir.
Yeah.
Thank you everyone for your presence over here. Thank you.